Hi, this is Miss Triangle, and this is your video for 5-7. So put the date and 5-7 using congruent triangles in the top right corner. You're going to set up your lines for your Cornell notes. You're going to write EQ. What is CPC-TC? And we'll write out what the full thing is in the learning target. So what is CPC-TC? Lots of C's in there. And our learning target 5G. I can use the CPC-TC to prove corresponding parts are congruent in congruent triangles. And that's what that stands for. Corresponding parts in congruent triangles are congruent. So it's an acronym so that you don't have to write this out every single time. Okay, so what is CPC-TC? Corresponding parts of congruent triangles are congruent. Congruent triangles have congruent corresponding parts. So if you can prove that two triangles are congruent, then you know their corresponding parts must also be congruent. So here's our first example. We have kind of a kite type thing, and I'll see if I can write on this to make it a little easier to see. Okay, angle 1, which is out here, angle 1 is congruent to angle 2. And angle RTQ is congruent to RTS. So that's what we know. Prove that QT, line segment QT, is congruent to line segment ST. Okay, so we know that angle 1 and angle 2 are congruent, so we can therefore say that angle Q is congruent to angle S because they are both linear pairs. So then we have an angle and an angle. We have two angles. Is there anything else we can add to our picture? Hopefully you're seeing this reflexive side. So we have angle, side. So we're going to prove the triangles are congruent using angle, side. Then the new thing we're going to add on today is after we've proven the two triangles are congruent, we are going to prove that two line segments are congruent. So I'm going to set up my table. All right, so angle 1 is congruent to angle 2. I always start with what's given, and I'm just going to put these together. Angle RTQ is congruent to angle RTS, given. Okay, we also know that RT, we'll do the reflexive side here, RT is congruent to RT because of the reflexive property, so that's our side. Then we need to talk about kind of that linear pair stuff and how we know that angle Q is congruent to angle S. So I'm going to say angle RQT, so that would be this angle right here, RQT, plus angle 1 is 180 degrees. That's just a linear pair, so I'll put linear pair. Same thing on the other side of my picture. Angle RST plus angle 2 are equal to 180. And those are also a linear pair. So then I can say angle RQT plus angle 1 equals, they're equal to each other, right? If they both equal 180, plus angle RST plus angle 2. And that's just substitution. So therefore, I can say if I subtract out the two congruent angles, I can say angle RQT is congruent to angle RST if I subtract angle 1 and angle 2, so that's subtraction property of equality. All right, then I've proven that I have two angles and a side, so I can say the two triangles are congruent. So I can say triangle RQT is congruent to triangle RST, and we use the angle side theorem. And then kind of the new part after you prove the two triangles are congruent, so normally this is where we would end. The new part is we're going to end with what it asked us to prove, right up here, that QT is congruent to ST, and our reason is going to be that corresponding parts of congruent triangles are congruent. So it kind of builds off of what we did earlier in the chapter. First, you prove the two triangles are congruent, then you end with a pair of sides or an angle, and your reason is the CPCTC. So how do you know you need to use CPCTC? If the question asks you to prove a pair of sides or a pair of angles is congruent. If it's just asking about triangles, you can end with that. All right, let's try another one. Prove that angle A is congruent to angle C. So I can already tell I'm going to need to use CPCTC because it's asking me about angles. All right, so it's already marked on here that AD is congruent to DC and that AB is congruent to BC. Is there anything we can add? Hopefully you're thinking that reflexive property. So to me, it looks like what theorem can we use to prove? Which of those 5 shortcuts? I'm seeing side, side, side. So let's start by writing our proof with side, side, side. So I'm going to start with AB is congruent to CB. That was given on our diagram. It was marked for us. Okay, AD is congruent to DC. That was also given and marked on our diagram with 1 tick mark. Then I'm going to do my reflexive side, the third side, so BD, or if you say DB, that's also fine, is congruent to BD, and that is the reflexive property. And then I'm going to say the two triangles are congruent, so triangle BAD. And if you do a different order, that's okay, as long as you list it. So I'm saying BAD, that would go with BCD. And we use the SSS, side, side, side theorem. And then lastly, I'm going to end with what it asked me. Angle A is congruent to angle C. Corresponding parts of congruent triangles are congruent. All right, let's try one. Okay, we're going to skip problem 3, and we're going to make this problem 3. So write down the given, the prove, the diagram. So we're trying to prove the triangle BCE, sort of this green triangle, is congruent to DCE, this yellow one. But first, in order to do that, we're going to prove that the two bigger triangles, CDA, is congruent to CBA, like if I split that one apart. And I can do that because I know angle 1 is congruent to angle 2, angle 4 is congruent to angle 3, and they share CA, that reflexive side, so I have angle, side, angle. So I'm going to try a paragraph proof for this one, just to see if we like it. So I'm going to say triangle CDA, that's the big one that I drew up there, is congruent to triangle CBA using the ASA theorem. How do we know that? The two sets of angles were given. And CA is reflexive. Then I know that CD, side CD right here, is congruent to CB because of corresponding parts, using corresponding parts of congruent triangles, CPCTC. Then using the SAS theorem, right, SAS right here. I have another pair of reflexive side. Triangle BCE is congruent to triangle DCE. That's it. So just try a paragraph proof just for something new and just to refresh us on that. All right, here is the summary and the homework. What is CPCTC? So what does it stand for? What does it allow you to do? So you're not proving two triangles are congruent. What are you proving? What do you need to do first, though, before using CPCTC? So hopefully you're saying that it allows you to prove a pair of angles or a set of sides are congruent, but first you need to prove the two triangles are congruent. Thanks for watching.